Good day, Mr. Simons here. Lesson number 3 on identities. We'll be looking at how to reduce our compound angles to prove identities, right? Problem number 1, they gave me sine 70 cos 10 minus cos 70 degrees sine 10 equals square root 3 over 2. So my left hand side is that, and we assume you remember, according to compound angle formula, you knew to grade 12 work, sine A minus B equals sine A cos B cos A sine B. So you see there's sine 70 cos 10 sine 10. So I can take this and reduce it to A minus B. So that simply becomes sine 70 minus 10. Gives me sine of 60 degrees, which the sine of 60 as a special angle is square root 3 over 2, which then equals my right hand side. Right, problem number 2. Right, now if we look at problem number 2, they gave me cos 69 cos 24 plus sine 69 sine 24 equal 1 over square root 2. So that's my left hand side. If I take my left hand side there, I must make it look like my right hand side. So according to compound angle formula, cos A minus B equal cos cos. See there, cos cos plus sine sine. Alright, A is 69 and A there is 69. B is 24 and 24. So only if we have the same angles can we reduce it using cos A minus B. So cos 69 minus 24 then gives me cos 45, and as a special angle, cos 45 is 1 over square root 2. On your calculator, you'll get square root 2 over 2. Now your calculator is going to rationalize. So this equals my right hand side. Alright, let's look at the next problem. Alright, now we have cos 291 degrees, cos 24 plus sine 111 cos 66 equal 1 over square root 2. Right, now first, my angles there, as I said in the previous problem, must be the same. 291 and 111 is not the same. 66 and 24 is not the same. Right, so because I have plus, I'm going to use cos A minus B. See there, cos cos plus sine. Right, and we must ensure that angle A and angle B are the same. So these two angles must be the same. So 291 falls in the fourth quadrant. So there cos 360 minus 69. That stays 24. 111 falls in the second quadrant. That is 180 minus 69. Second quadrant, and cos 66. See there it says cos cos sine sine. To make the sine sine, I must use 90 degrees. Alright, so that's cos 90 minus 24. So we reduce using the cast rule in the fourth quadrant. Cos is positive, so that simply becomes cos 69. That stays cos 24. My plus stays, sine stays plus. 180 minus 69 in the second quadrant, sine is positive, so that stays sine 69. And cos 90 would become sine, but 90 minus is first quadrant, so therefore stays positive, sine 24. So now I have cos cos, sine sine. I can reduce it and it becomes 69 minus 24, which then gives me the cos of 45 degrees. And that there again is 1 over square root 2. So now my right hand side and my left hand side are the same. So I've proven identity. If you enjoyed the lesson, please like, share and subscribe. Alright, problem number 4. Gave me sine 10, sine 70 plus cos 350 sine 160 equal half. Again, I must make them look the same. So they are 10, that must become 10. This is 70, I must make that 70. So according to compound angle, sine A plus B is sine A cos B, cos A sine B. So I'm now just working, could have changed this to cos cos and sine sine, but just working with sine cos, cos sine. So there, to change the sine to a cos, I'm always going to bring in 90 and say 90 minus 20 degrees. The 90 will change sine to cos. There A, I must get 350 to be the same as 10. So there 360 minus 10 degrees. Right, gives me 350. And then sine B 160 to get it to become 20. 180 minus 20 gives me 160. Right, so sine 10 stays 10. 90 minus 20. 90 changes sign to cos. 90 minus any acute angle is in the first quadrant, so therefore cos 20. 360 minus 10 is in the fourth quadrant, and in the fourth quadrant cos is positive, so that simply becomes cos 10. And 180 minus 20 falls in the second quadrant where sine is positive, so that becomes sine 20. So now you see I've got 10 and 10, same angle, 20 and 20. So now I can work vice versa and reduce, so that would become 10 plus 20. 10 plus 20, 30 degrees, and the sine of 30 equals half, which equals my right-hand side. So hope you follow, I hope you enjoy the lesson. Don't forget to subscribe.